Hello. So I've been messing around with lock-in amplifiers and I'm trying to understand those and how they work. So usually what you have going on, at least a lock-in amplifier for say like a ultrasonic transducer, which is what I've got going on here. Usually what you do for a lock-in amplifier is transmit some signal with the transducer, or you can use radio waves, whatever, at a known frequency and phase, and then listen for it on another transducer, or sometimes a antenna, or even the same antenna. There's heterodyning systems like that, and then compare the received signal's phase with the transmitted signal's phase. So you can look at the Doppler shift of the signal and get information back from that. So a lot of the time lock-in amplifiers are made with expensive analog multiplier chips. So in this case, instead of doing that, this is a chopper style lock-in amplifier that just multiplies the signal by 1 or -1. So it switches between inverting the signal or just buffering the signal. And of course, I got an amplifier and a preamp and all that for the transducers, but the juicy bit's really just the two multipliers, or in this case, chopper circuits. So it's all based around op amps and just a 4066 quad bilateral switch chip and some inverters for timing and to create an edge trigger system and blah blah blah. So mathematically, what's going on here is this is. You can think of this as my 40 kilohertz sine wave, which is coming from a function generator, the WaveTech function generator. And my circuit listens for an edge, rising and falling, so it produces a square wave in phase with the transmitted sine wave. And then, using an RC delay, I also have another square wave that's 90 degrees out of phase. Then the transducer receives that 40 kilohertz wave back. Of course, it would be attenuated, and there's going to be noise in it and all of this, but really to demonstrate a clean wave reception is nice to assume. Besides, that wave there is not the function generator, that's the received wave. So it's clean enough. So yeah, this received wave is then multiplied by these two square waves. So you get a waveform that looks like that, and a waveform that looks like that, at least at this particular phase instant. So then what happens is when you have something reflect the wave or change its phase, that's kind of like doing this, sliding the wave along, and these are the outputs you get. So this is what I get out of my chopper circuits, and then it's filtered down. So sort of the kind of center of mass of where this wave is drawn is what the result would be. Just put it through a low-pass filter. And that's what this circuit is. And just doing it with inverters and 4066 switches and some op amps. Now, really what I want to do is do the triggering system and the chopper control system with a microcontroller, because then you can use more interesting chopper profiles. For example, rather than chopping by this square wave, I could do something like this. So the middle would be high impedance, so it would basically be multiplied by 0 in a way, and then multiply by 1, 0, -1, 0, 1, 0. And also the symmetry of this could be changed, etc., and you'll get different harmonic output. It'll listen to different kind of parts of the signal. So yeah, I have one of the channels out of this, I think it's the reel, hooked up to my sound system here. And the reel and complex are plotted on the scope. something else kind of fun that I played with is if you feed this a frequency modulated signal, the IF does spit out a tone, but something interesting happens. As things move away from it, the pitch bends up. As things move toward, pitch bends down. Or I can change that modulator to something lower. So that's kind of fun. Anyway, that's a probably very wobbly video of what I've been doing lately. Later.